Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about section of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's problem is related to a solid which has been cut by a section plane which happens to be inclined to HP and perpendicular to the VP. So here such cutting planes, they are called auxiliary inclined planes. So here we have a cutting plane, you can see, which is inclined to the horizontal plane and it happens to be perpendicular to the vertical plane. So what the cutting planes of this nature, they will be called AIP. So let us see one of the examples over here. Here we have an AIP which is inclined with respect to HP at an angle of theta, and this plane happens to be perpendicular to the vertical plane, and this is going to cut the solid in this inclined orientation, and this portion of the solid will be discarded and it will be thrown out, and then we are left with the remaining portion of the solid. So here we are required to draw the front view projections as well as the top view projections of the solid, and whenever we draw the top view of this solid or even this solid, now we are going to see the reduced or the shortened projections of this cut section onto the horizontal plane. So since the top view which we are going to obtain will reveal us with the section top view, which will be the apparent shape of this cut section. Why? Because this surface which is inclined one, it is inclined with respect to the horizontal plane, and because of this inclination of this cut section with respect to the horizontal plane, the projections obtained on the top view, that is on the horizontal plane, will be the shortened view. So we have to go parallel to this cutting plane in order to obtain the true shape of this cut section. So for that purpose we are going to draw an AIP over here which will be parallel to the cutting plane, and whatever projections will be drawn on the AIP, that is the auxiliary plane, they will provide us with the true shape of this cut section over here. So let us work out that what type of problem we are going to solve. So during this lecture, so here we have a hexagonal pyramid which has been cut by an AIP which is inclined with respect to the horizontal plane at an angle of 30 degree. So here you see, here we have the top view because the solid is resting on the ground on its base. So the true shape of the base of the solid will be drawn in the top view on the horizontal plane. So this will be drawn below the XY reference line. And then once we draw the front view of the solid, so we work out that the cutting plane is going to pass through the axis at a distance of 20 millimeter from the top, and once the cutting plane cuts the solid over there, so 6 points of intersection we are going to work out. Why? Because this cutting plane passes through all the generators basically. So all the generators, they have been cut, so that is why 6 POIs they will be observed. And now in the front view we are going to get the edge view of this solid of the cut section, and in the top view if we draw the projections of all these POIs, we'll find that the projections which are obtained in the top view, they will be the section top view projections, and they will be shorter than the actual shape and size of this particular cut section. Why? Because this cut section happens to be inclined to this horizontal plane. So we are going to get apparent projections for the cut section. Similarly, whenever we draw the side view also, so again you can see this cut section is again inclined to the side view or the profile plane as well. So this is the profile plane. So even if we draw the profile plane projections over there, that is the side view, again in the sectioned side view we are not able to obtain the true shape of this cut section, and we will be able to draw the true shape projections only when we draw an auxiliary inclined plane parallel to this cutting plane, and whatever projections of points of intersections are drawn onto this AIP in the form of the auxiliary plan. So these projections will provide us with the true shape of the cut section, which is this one. So we can see over here that this true shape is bigger than the apparent shape which is obtained in the top view, as well as this is bigger than the apparent shape which is obtained in the side view. And again we can check, because the angle of inclination of this plane with respect to the profile plane is more, so the shape obtained is even shorter, whereas over here with the HP the angle of inclination is less, so that is why shape obtained in the top view is bigger than the shape obtained, that is the apparent shape which is obtained in the side view. So let us work out the projections of this hexagonal pyramid, which is cut by a cutting plane which is inclined to HP and it is perpendicular to the vertical plane. So let us go through the statement. Now here we have a right regular hexagonal pyramid having the base edge 25 millimeter, axis is equal to 50 millimeter height. It is resting with its base on the horizontal plane. That is, since it is resting on its base on HP, so the top view of the base, that is this hexagon, will be drawn on the horizontal plane, right? So this will be drawn below the XY reference line, and this hexagon is having one of its base edges perpendicular to the vertical plane. So here you see these are the two orientations in which we could have drawn the hexagon below the XY reference line. Since this hexagonal pyramid is having one of the edges of the base perpendicular to VP, so this is the incorrect orientation of the hexagon. So this cannot be drawn below the XY reference line. So we cannot pick this up, this orientation. So we have to go by this orientation of the hexagonal base, so that one of the edge, you see in this case none of the edges of the base, they happen to be perpendicular to the vertical plane, whereas over here two edges, they happen to be perpendicular to the vertical plane. So this is the orientation of the hexagon which we are going to draw in the top view corresponding to the base of this hexagonal pyramid. And then this hexagonal pyramid is cut by a section plane which is perpendicular to VP and inclined to HP at an angle of 30 degree. That is an AIP which is inclined to HP at an angle of 30 degree. It cuts the axis and it passes through the point 20 millimeter below the vertex, that is from the top corner, that is apex or vertex, you measure 20 mm below on the axis. So cutting plane will be passing through this point, and since this cutting plane passes through all the slant generator, you see these are all the slant generators. So since all the slant, you see, edges of this hexagonal pyramid, they have been cut, so we are going to get POI, that is points of intersection, is equal to N. N means edges of the base. So since all the slant generators, they have been cut by this cutting plane, so we are going to get 6 points of intersection by virtue of cutting off this hexagonal pyramid by the cutting plane. So let us start drawing the projections. So to begin with, we draw the XY line. Having drawn the XY line, now in the orientation that we have discussed, we are going to draw the construction of the hexagon base over there. So the top view will provide us the projections of the base over there. Then corresponding to the apex, now all the slant inclined triangles, we have triangular faces now we are going to draw. So for that we need to draw the axis over there. So 25 mm is the edge of the base of this particular hexagon. Now we are going to join these diagonals, but before that let us do the numbering. So A, B, C, D, E, F, these are the corners of the base, and now once we join the diagonals, you can see wherever 3 diagonals they are going to intersect, we get the axis point of this particular hexagonal pyramid over there. And now you see, otherwise we would have had this problem not been related to section of solids, we would have joined all these lines or the diagonal points in a darker way, because in this case we are going to cut the top portion of this particular solid. So that is why we have drawn solid lines, but they have not been darkened over there. So these are the slant faces. You see, these are the slant edges, OA, OB, OC, OD, OE and OF. These are all the slant edges. These are the slant edges. And then few slant, or rather all the slant edges, they will be cut by the cutting plane in the different orientations. So that is why we have not darkened these slant edges over there. And these are the triangular faces of corresponding to these slant faces over there. So now draw the front view, because the edge of the base is resting onto the ground. So the front view corresponding to the base points will be located onto the XY reference line. That is, once you draw the projections from BA, CF and DE onto the vertical plane, so all these points, they will be located over here onto the XY line, that is onto the ground. So let us draw the front view. So this is my axis point. Just see, I have drawn the axis. Axis height for this pyramid is given to me as 50 millimeter. So I have drawn the axis height equal to 50. Now I can join the projectors over there corresponding to the slant edges. Now you can see once again, I haven't darkened this, I haven't darkened this, or even I have not darkened this portion. Reason, because this solid will be cut by a cutting plane in certain orientation. So let us work out that orientation. So I have joined O dash A dash, O dash B dash, O dash C dash, O dash F dash, O dash D dash and O dash E dash. But here we must remember projections of OA, they are over here dotted ones because it lies on the back side, but they have been overpowered or superimposed by the projections of OB. That is why no hidden line is shown over here. Similarly, projections for OF, again O dash F dash, they are dotted, but still they are overpowered by or overshadowed by or covered by the projections of OC. So that is why again we get a solid line. Similarly over here, projections of OE, they should have been dotted because it is on the back side, but these dotted projections have been overpowered by the projections of OD. So O dash C dash, O dash E dash we are not showing as dotted because it has been overpowered or it is being coincided by projections of OD over here. That is O dash D dash, it coincides with the dotted projections of O dash E dash over here. So that is why all the three projections which are visible in this view, they are solid. So we haven't darkened it. We will be darkening it once the cutting is done by the cutting plane over there. So now we have our cutting plane, which is an AIP. It is going to cut this solid 20 millimeter below the vertex or the apex. So we have measured this distance equal to 20 millimeter. Now the angle of inclination of this AIP is 30 degree with respect to the horizontal plane. So just see, this is an angle of 30 degree with respect to the horizontal plane. So this angle is 30. So obviously here you can get 60 degree because this angle is 90 degree over there. So we have marked this angle as 30 degree. Now this cutting plane is going to intersect all these 6 slant generators which were there. O dash A dash, O dash B dash, similarly O dash C dash, O dash F dash, and similarly it is going to cut O dash D dash and O dash E dash. So all the 6 generators have been cut. So there are going to be 6 points of intersection. But before that, let us join the remainder portion because this portion of the solid has been cut and it has been discarded. It has been thrown out. Now let us join the remainder portion of the front view. So we can darken this because this is the remaining portion. We can darken this, but again this is the remaining portion and this is again the remaining portion of the solid. That is the slant generator, whatever is remaining over there. So this is the longer, you can see generator left, this is the shorter generator. So this is the shorter generator, This one is the longer side of the generator. Now 6 POIs are there, so the front view of the cut section has been obtained, and this cutting plane is cutting all these generators. So we'll work out the different points. So 6 points of intersections will be there because all the generators, they have been cut. Now this is not passing through the base, so no additional POIs will be generated in this particular case. Now let us start with working out location of these POIs onto the slant generator. So this is my projection of O dash A dash and O dash B dash, right? So these are two generators which are lying in the same orientation. So both of these generators, they have been cut by the cutting plane at this point. So the names of the points will be 1 dash and 2 dash. 1 dash point will be lying on O dash A dash, and similarly 2 dash point will be lying on O dash B dash. Now we will be transferring these points in the plan view over here. So let us do it. So please check, I have drawn a vertical projector line, right, corresponding to these 2 points. So let us mark these 2 points. So the names of these points I have marked as 1 dash and 2 dash. And again, I have already told you that 1 dash point will be lying. It is the point of intersection of the cutting plane with the slant generator O dash A dash. Similarly, 2 dash is the point of intersection of the cutting plane with O dash B dash. So let us now transfer these points, corresponding points on OA and OB. Just see, we have drawn the vertical projector through 1 dash and 2 dash. So wherever this projector intersects with the top view of the slant generator OA, I get the point 1 over here. And similarly, wherever this vertical projector intersects the top view of the slant generator OB, I get the point 2. So point 1 dash and 1, they fall in one line. Point 2 dash and 2, they fall in one vertical line. So I have been very easily able to locate these 2 points. Now let us work out the second couple of points which are going to lie over here. So please check, my cutting plane is going to intersect the slant generator O dash C dash on the point 3 dash, that is POI will be 3 dash. Similarly, O dash F dash is being cut by this cutting plane or intersected by this cutting plane at the point 6 dash. So let us try to shift or bring these points in the top view. So please see, as I am going to bring this down, I don't find any point of intersection. Why I don't find any point of intersection onto O dash OF or OC? Because there is a vertical line. It is just similar to the situation which happened in the case of projections of the cone. So in the section or projections of the cone, again the points which were lying on the axis, they were not easily located over here. So what have to be done? You see, these are the 2 points 3 and 6 over here. If we are looking from this side, these 2 points, they will be going like this over there, right, in the top view. So you are not able to locate them over here. So what we need to do, that rather than looking from this side, we need to look from the 90-degree perpendicular side over here. Just see, we must look from here, and once we are looking from here, you see these 2 points, that is the distance of this point from the center and the distance of this point from the center, because these points, they are symmetric. So this midpoint has to be located over here. So if we are looking from the same end, these points will be projected. You can see 3 dash and 6 dash, they are projected downwards, but they are not intersecting anywhere with OF or OC. So for that, similar to the way we projected the POIs which were there in the case of axis, in the case of a cone, same procedure will be followed over here. That is, I have to look from this side. If I am looking from this side, I will be easily able to obtain this distance or this radius. The moment this radius is obtained, I can shift this radius over here, and I can easily shift this radius over here. So let us now start looking from the side 90 degree. It means rather than looking from here, start looking from this side. so that this radius can be obtained. So how that can be done? Please see. From 3 dash and 6 dash, draw a horizontal projector over there. Just see, I have drawn a horizontal projector to intersect O dash A dash and O dash B dash. So this is a horizontal projector is drawn just to verify how much radius will be there corresponding to this height. If the cutting plane would have intersected here, just see the radius would have been lesser. Had this cutting plane intersected with the axis over here, the radius would have been more. Had the cutting plane intersected over here, the axis, the radius would have been even more. So there is a direct relationship between the height of the point of intersection from the base of the solid and the radius which is going to be obtained. So larger this height, lesser will be the radius. You see, larger the height, lesser is the radius. Lesser the height, more will be the radius. So this way I know the height, that is this height is there from the base, and then I am going to take this to the right so that I can look from this angle. The moment I take it to the right, so which point I have obtained? I have obtained one point of intersection on the slant generator O dash A dash and O dash B dash. Now this radius I am going to transfer in the plan view, and in the plan view on which generators this will be transferred? Again on OA and OB. So please see, I am going to transfer this point, that is this radius I am going to transfer. So I have drawn a projector. Just see, I have drawn a projector. Again a projector has been drawn. Now once this projector is drawn, I will locate these 2 points. This is corresponding to point number F. So this point will be corresponding to 6. This point is located corresponding to C. So this point is construction point for radius for 3. So what I am going to do, these 2 points, even though the radius remains the same. So what I am going to do now, please check. Since this is parallel to XY, please check. Since this construction line happens to be parallel to XY, so the projection which is obtained in the top view, it is the true length. Please check this out. This projection which I am going to obtain corresponding to point 6, corresponding to point 3. So these 2 projections of the radius, they will be the true lengths of the radius over there. Why? Because this projection which I had drawn to look at this object from the side view over there. Now having obtained this radius points, this is radius point corresponding to 6, this is radius point corresponding to point 3, POI 3. Now I will have my needle point over here, open compass up to this much. So this radius is equal to same. Now keep your needle here, open compass this much, draw one arc which will be taking it back to the point 6. So this will give me the location of point 6. Similarly, open compass this much. Obviously this radius and this radius, they are the same. Again, keeping needle over here, open compass this much, and then draw an arc to meet OC over there, so that this true length of the radius is shifted onto the plan projection for the OC. Similarly, true length of this radius for 6 has been transferred to the plan projection of OF. So this gives me 0.6, this gives me 0.3 over there. So this is the same thing which we did even in the case of section of cones over there. Next, another 2 POIs are there which are going to cut my slant generators O dash, D dash and O dash, E dash. So my cutting plane is going to cut these 2 slant generators at the points 4 dash and 5 dash. 4 dash will be corresponding to O dash, D dash, and 5 dash is corresponding to the generator O dash, E dash. So from this POI, common POI for 4 dash and 5 dash, again I am going to draw a vertical projector. Just see, I am going to draw a vertical projector. So it is going to cut OE over here. So this gives me the location of 0.5, and it cuts OD at this point. So this gives me the location of 0.4 over here. So all these 6 points, they have been located in the top view. Now having located these 6 points, I need to join these 6 points to obtain, you see, the edges of the cut section over here. 6 points have been located. Once I join them, I am going to get the generation of the edges of the cut section, and this is the shape of the cut section as it is viewed from the top. So when the observer is going to look at this cut section from the top, so this view the observer will be getting, but this surface happens to be inclined to the horizontal plane. So the projections obtained corresponding to these 6 POIs onto the horizontal plane will be apparent shape. So we are not going to get the true shape of the cut section over here. And we have done the sectioning, hatching is done, 45 degree with respect to the XY reference line. And whatever remainder, you see, whatever remainder of the slant edges, they are left out. All those slant edges we have joined. So A1 remaining slant edge, B2 remaining slant edge, C3, D4, E5 and 6F, they have all been joined. So this way the top view has been obtained by showing the original solid, remaining one, and the cut section of the cut solid over here. So this is the apparent shape of the solid, or we call this as sectioned top view, because it does not show the true shape. So another AIP has to be drawn over here. But before that, in this case, we are also required to show the side view. The sectioned side view we are required to draw. In order to draw the sectioned side view, this will be drawn in the profile plane. So X1, Y1 reference plane, that is corresponding to the profile plane, will be drawn, and then horizontal locus lines will be drawn from all these points, and then these points, they will also be transferred over here, and then these will be rotated here. So let us find out the corresponding point. So just see, all these 6 points of the base and the axis point, they have been transferred over here, and then there are 2 ways to transfer it onto the profile plane. You draw a transfer line at an angle of 45 degree and extend this and take all these lines up, or else you can draw the curves over there, so that these distances, they are appropriately transferred onto the profile plane. So we have used the curve method. Otherwise, you could have drawn this transfer line 45 degree, draw the horizontal line, draw the vertical line, draw the horizontal line, draw the vertical line. So this way even you could have transferred these points over here. So whatever things you are able to see over here, they will be appearing in the vertical direction. Now draw the horizontal lines through the elevation view and find out the corresponding point. So please check, A, B, C, D, E, F points, they are lying on the ground. So A double dash, B double dash, C double dash, D double dash, E double dash, F double dash, these points will be referred over here. But let us find out these points over here, because here we had the diagonal like this. A and E were coming to be there on the extreme point. Now C and F, they will be coming under the extreme point. So point F will be shifted here, point C will be shifted here. So please see, we are looking from the side. This point F will be located here. This will be called F double dash. A and E, they are appearing here. We call this A double dash, E double dash. B and D, they have been shifted here. So B double dash and E double dash will appearing over here. Similarly, this is locus for C. So C double dash will be appearing over here. So this is how these points, they have been transferred in the side view. Now we transfer the axis, and now we can join the slant edges over there. So this is my axis point, and then you see another thing. These are my slant generators over there. Right now I need to find the cut section. So 2 methods to do it. One way is, you have 6 points over here, transfer these 6 points in the same fashion over here, or else you have 3 points over here, 3 points of intersection, that is the 3 pairs of points of intersections are there. Now through these 3 pairs of points of intersection, that is 6 POIs are there. Now take every pair in the horizontal direction. Take another pair in the horizontal direction. Take another pair in the horizontal direction. Let us find out first pair. First pair is 1 dash and 2 dash. So these POIs, they were lying on the, you see, slant generators O dash, A dash and O dash, B dash. So 1 dash was lying on O dash A dash, 2 dash was lying on O dash B dash. So let me take it here. I am drawing the horizontal projection from here. So where does, you see, A and B, I am talking about A and B. Where does A lie? A lies here. So my slant generator in the side view is O double dash, A double dash. My slant generator corresponding to B lies here, O double dash, B double dash. So wherever this intersects 1 dash and 2 dash with A dash projector line, A double dash projector line and B double dash projector line. You see 1 dash horizontal line I have drawn. So wherever it intersects O double dash, A double dash, I get the point 1 double dash over here. Similarly, I have drawn a horizontal projector from 2 dash. So 2 dash was lying on O dash, B dash. So the side view will lie on O double dash, B double dash. So this point will be my B double dash. Similarly, 3 and 6. So 3 dash and 6 dash, they were lying on O dash, C dash and O dash, F dash. Now I take this locus line. Where does C lie? Here. Where does F lie? Here. That is outermost generator. So if I draw a horizontal line, wherever it intersects O double dash, F double dash, point 6 double dash is created. Similarly, wherever this horizontal line, it is going to intersect with O double dash, C double dash, I get the location of 3 double dash over here. Similarly, 4 and 5. So where they were located, O dash, D dash and O dash, E dash. Where does D dash lie? Here. That is this point. Where does E dash lies? Here. So now I take the horizontal projector from here. Wherever it intersects with O dash, O double dash, E double dash, I get the point 5 double dash. Similarly, wherever this horizontal line intersects O double dash and D double dash projector line, that is slant generator, I get the location of 4 double dash. So all the 6 points you see I have been able to locate. Now I am going to join these 6 points. So these are the POIs in the side view. Again hatching, let me put down the numbering. 1 and 2 they were lying here. So 1 double dash, 2 double dash. 3 and 6 they were lying here. So this is 6 double dash on F double dash line and this is 3 double dash on the C double dash line. 4 and 5 they were lying over here. So 5 is lying on E double dash locus line and 4 dash double dash is lying on D double dash locus line. So this is my side view. Now you can see angle with profile plane of this surface is 60 degree. It is higher with the profile plane. This angle is 60 degree. So reduction is more. Angle of inclination of this cutting plane with respect to HP is 30 degree. So reduction is less. So this apparent shape is bigger than this apparent shape which has been viewed over there. And once again, this is the apparent shape of the section view. Now we can join these remaining slant generators over there. So just see, remaining, we are looking from this side, you see. So this remaining generators we have to join, right? So these are the 4 generators, 1, 2, 3 and another one. This one will be visible from the side. So this is my side view, section side view of the cut solid. Now having drawn the section side view, which is again the apparent shape, having drawn the section top view, which was again giving us the apparent shape of the cut section, I want to now draw the true shape of this cut section. So how this will be possible? This will be possible by looking at this cutting plane from this direction. That is, I am going to draw an AIP and I will be looking at this AIP from this orientation. So we are going to assume this is a solid which is transparent and this opaque portion is there. So cut surface we will assume as an opaque surface. And now generators, through these 3 pairs of projectors we are going to draw onto this particular AIP. So this is AIP and the projection which will be obtained on AIP will be auxiliary plan. So the distances of the plan from XY regarding these 6 POI, that is distance of 1, distance of 2, distance of 3, distance of 4, distance of 5 and distance of 6. So all these 6 distances will be plotted onto these projectors. Just see, 3 projectors we have drawn through these 3 pairs of the POIs. So now we are going to transfer the distances of all these POIs in the plan with respect to the XY line onto this auxiliary inclined plane, so that we obtain the auxiliary plan over here. So just see, these 6 points, they have been transferred. So let us see how we have transferred. Distance of 1, it is lying on this POI locus line. So this is the distance of 1. So this distance of 1 has been transferred over here. This distance of point 2, it is equal to the distance of POI 2 in the plan from the XY reference line. Similarly, distance of the point 3 from the XY reference line in the plan has been transferred over here. Next, distance of POI 4 in the plan from the XY view, it has been transferred over here. And similarly, the 5th point. So all these points, they have been transferred. We'll do the hatching, and once we do the hatching over here, next we are going to get the true shape of the cut section over here. So the true shape of the cut section has been obtained. Why? Because our auxiliary inclined plane, it happened to be parallel to the cut section over here, or the cutting plane. So since the cut section was parallel to the AIP, so we have been able to obtain the true shape in the auxiliary plan, which has been obtained on the AIP. So therefore, by using the principles of projections of solid, sections of solid, and auxiliary planes, we are able to work out the section top view, section side view, front view of the cut solid, and the true shape of the section portion of the solid. So all these aspects, they have been evaluated. So this is all about the discussion we wanted to make for today. So I hope with this discussion you would have understood about how to draw the projections of the cut sections of the solid whenever the solids, they have been cut by cutting planes in any of the orientations, right? So we are going to continue with further discussions on few more cases of section of solids in our next lecture in this series of the lectures over there. So thank you very much. Thanks a lot.